Okay, so hello everyone. Am I audible? Can someone confirm? Yeah, okay, thanks. So I'm closing the camera for better bandwidth. So in this week of problem solving session, I will mostly dedicate this problem solving lecture to solving the questions of the previous year assignment because there was nothing like that needs to be covered that much. Yeah, but I am just briefly telling what was covered this week. So in this week, mostly uh, the compilation part is covered, in which there were three stages. First was pre-compiling, then generating the code, then there is linking. So in pre-compiling, we include all the libraries and the codes in header files that needs to be there while using uh, while executing that code, and from that actually we try to get the overall code to get the executable. So for example, we have has include stdio.h. So whenever we go through or to provide the code to the compiler from C, it first goes to the compiler, and the compiler adds the code that is there in header file stdio.h. And if we actually create some function, store it in some header file, some custom header file, it also occupies that header file with that code. And then in second phase of compilation, we actually provide that overall code for compiler to provide a object code which can be executed at different machines using different languages, and that code is actually provided to the linker in the third stage, and the linker actually takes all the executable all the object files, all the codes. Uh, like if there is a file having main function and there is a header file having some function of summation, which is mutually exclusive of that. Before linking, the linker links those files and provides an executable. That is the overall thing in theory that is covered this week. So today I will basically focus on all the problems given. There are 24 different problems in the previous year assignment. I will dedicate the full session on this, and if something remains and the remain part of previous lectures, that was 2, 3 questions, that all thing I will cover in the last week. I will cover all the things from first lecture up to the last lecture. I will summarize first, and will complete all the things in the next one, that is the last problem solving session. Today I will just focus on all the things which is covered related to compiler. So compiler is kind of um, intermediary between you and the system. So in later part, there were some questions solved, uh, which tells how the base pointer and the stack pointer and the instruction pointers are manipulated or updated during the execution of instructions. That I will also cover through an example which was asked in previous year assignment. So till now 12 has joined. Let's wait for 2, 3 minutes, and then I think I will start the question. So we will start from this one. directly to the question for problem solving. So I am opening Q&A. Yeah, good evening. Thank you, Kumar. Good evening. So, okay, like previous lectures, you can use Q&A for asking and answering me the solution. So first one is the very simple one. I think you can see and just answer. So let's start the party of doing questions. So anyone who can answer this, just write on the chat box. Option C. Option C. Option C. Is equal to A. No, it's not actually the answer. Any other? It's very simple one. There is nothing to care about. It's a very simple one. We don't have to think about any assembly code or anything because it's just about basic understanding of C and the compiler. Yes, yes. Because we are taking a character array, and here what we are doing, we are just taking this stdio.h. Then we have defined this macro variable, a macro string. Okay, and then we provided this character array, the macro variable. So this is now stored here. And when we will print, we are asking for %s. So it will take this string and a. We have to print a there. So a is actually taking the value this, which is actually this thing. Okay. So what we will be with the answer, we will write macro is equal to %s will be occupied with this value, that is this one. So answer will be A. Macro is equal to macro. It's very simple one. There is nothing to think more about. Okay. Now coming to this one, it's a simple understanding based question regarding pre-compilation and then compilation. Uh, which of the following statements is or are true? The pre-compilation replaces macro by its value macro only where it appears as C macro. Statement 2 is global variable declaration. The compilation replaces macro by its value macro only when it appears as C macro or none of the above. Just answer it. Just think and answer. Yes. God is answer. C. No, it's not about compilation. You are very close. See, what happens during compilation and what happens during uh, pre-compilation stage. So in pre-compilation, if you want more clarification, you can see the lecture also. I'm just briefing you. In pre-compilation stage, if we have something in has include, has define, or anything else, say here is I have stdio.h, then I have has include some library, some header file we created f2.h, not like this. So during pre-compilation stage, it will actually add the code, uh, means it will actually create the object file which will be added to the code during executable creation in the linker. So all of these files will be included to the code during this pre-compilation state only. So now can anyone answer? It is there in I think lecture 11 only. I will wait for 1 more minute if someone answers. None of the above definitely is not the answer. This is also not the answer. The answer is either one or two. Okay. So answer will be one. It is done during pre-compilation stage. Okay. The macro will be replaced by its value where it appears in C macro. Yeah, good. Right, Sai Kumar. Okay, coming to the next one. Yeah, it's multiple select question, so there may be more than one answer, right? So I'm just reading it for you. Linker combines all object files and generates an executable. If statement one of a C code of the C code is removed, a compilation error will is thrown. If statement one of C code is removed, a linker error is thrown. Or if statement one of C code removed, no error is reported. What is statement one? I am showing you. Statement one is this has include stdio.h. Now, can you answer this? It's a very simple. Please write the answer. Wrong answer is also good and better than sitting idle. Just try answer. If it will be wrong, I will correct you. Yes, good. So first statement is obviously right because linker combines all object files and generate an executable. It's a work of linker, so it's correct. And second is how it will be correct because because if you will just eliminate this line, if you have eliminated this line, what will happen? This code, this header file is having this printf function. It will not be it will like the code will not have the definition of printf after removing this line. So it will actually throw the compilation error. Okay, not the linker error because the linker's work is different and error will be there. No error will not be the option. So answer is the A and B or one or two as you can remember. Okay, what errors or error occur when the following code is compiled and executed? Which kind of error it will be, or there will be no error? Can you please comment? Mm-hmm. How it can be a compiler error? Compiler error will be there when there is something missing. Is there something missing in that? Tanmay, good. Uh, it will not be a compiler error because main function is actually calling the callee. Okay, so callee is actually called. Here we are uh, calling the callee one, and it is defined. But problem will be when we will go for compilation and we will be generating the object code or object file like what it does. Linker does this object files and generates an executable. So when linker will get the object file of this callee one, there will be nothing in that. Okay, so there will be linker error because it will not be able to link anything with that. So answer is B. Compilation error will not be there because everything which is under this main function is having definition, and assembler error is different thing. Okay, coming to the next one, what will happen in this? Oh, where is the fifth one? I missed the fifth one. Okay, no problem. It has only one option correct. Can someone answer? Number one. Good. It is compiler error. Why? Because it is calling the callee function, callee1 function, but there is no definition of it in this C code. That's why when it will call this function, it will not get the definition and throw the compilation error. Yes, good. Into the next one. Just if you want to write this code, just write it. I am just pausing it for 2-3 minutes because we will use it. Okay. So it's 7:21. I am opening this thing till 7:25. Just write it somewhere because we will use it to answer the question 7 to 21. So it will cover a greater part of today's lecture, or you can say today's problem solving session. And we will do all the things which are covered in the lecture using this example only. Okay. So the following C program is compiled to be unoptimized assembly equivalent code shown below. It is the C code. I will show the assembly code also. I will open that for you for 4-5 minutes also. You just start writing and note it somewhere so that if we will go for the answers, we will not get stuck. Sai Kumar, 0 cross 1, 2, 3, 4. If you convert it to hexadecimal, it will be 4444 bits, as per my understanding. So, like if you want to convert it, I'm just writing it here for your purpose. You are having this 0, 1, x, 1, 2, 3, 4. 0x means you are writing it in hexadecimal. Okay. So, in each hexadecimal digit that is represented by 4 bits, or 4 bits are also called nibble. Okay. So, if we will go like this, so hexadecimal digits will be uh, like this: 0, 1, 2, 3, 4, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0. Okay. So, all are single bits. So 4 bits, 4 bits, 4 bits, 4 bits. So it will be 16 bits as per my understanding. Or you can say 2 bytes also. Got it? Yeah. So 2 more minutes. Just copy it. Then I will change the slide so that you can copy the assembly code also. And then we will jump to the next 14 questions. I think it's the most essential part of this overall course, because here you will go through all the things. This is the site. Tanmay, you can treat me like a third party which is just given instruction to take the problem solving session. I don't have any information regarding the exams or how it happens. So I just know the syllabus. I have the solutions of previous year questions, and I have to discuss it with you with some additional questions if needed. So I can't comment on this site, means whether we can you can like access or not. Okay, last minute. Okay, I'm changing the slide. So I am telling it in brief what this code is for. It is for surface area. Okay, so we have three variables of data type sort. So these we have as the function parameters: length, uh, width, and height. And then we have this surface area, then dummy. All these two are also sort, and it will just calculate this LBBH plus HL. What is the formula? That is the formula of surface area. And then we have this, we have to return this. And in int main, we have the Z, Y, and dummy 2. Z will call this surface area with some parameter. Dummy 2 will be Z, and we will return the integer value of Z. That is the overall code is all about. Now I am changing it to its unoptimized assembly version. Okay, so I am opening it for 5 to 7 minutes. You just write it somewhere. So till you are writing, I am just uh, telling it in brief. First, there are two things. There is code segment address of main, and there is code segment address of surface area function. And then there are addresses, and corresponding there are translated assembly code for main function and surface area function. So everything is happening using this code, and this all overall code is actually derived from that C code only. So what is happening here? We are first pushing the EBP that will actually create the original pointer from where we will start the code. Okay, and then we will go for moving ESP to EBP, means stack pointer to base pointer. Then we will provide subtract ESP and 0. So what it is telling, can anyone write? It is covered in lectures. So I am just telling, okay? You just copy it. So this instruction is actually responsible for allocating the local variable space. Okay, so local variable space will start from N0. Then we will push three variables, N1, N2, and N3. After that, we will call this address 1. Okay, and address 1 will take us to this surface area function. And after that, uh, our stack pointer will point to value 2. Then there is a move pointer, move AX, word pointer, and all. Those are responsible for these calculations. And then at last, if you see, we move this ESP, EBP to ESP. Means we actually uh, took the part which is in base pointer to the stack pointer, and then we pop out what is in base pointer, and return 0 will actually pop out the overall thing, the calculation what is carried out. Now coming to the surface area one, surface area may we actually did push register 1. So register 1 will actually take care of first value. What value it will be, I will tell after this. And then we all have this uh, moving the value from register 2 to register 1. After that, we have again this stack pointer subtraction with N5 that will actually create so you are moving E0. So Let's start solving this. A good question. So let me start from this 0x f0 move A and immediate transfer to 2. So after this instruction, this will move the value 2 to register A. Okay. So what will happen? It will dedicate A is equal to 2. In second instruction, 0x f2 move B. That is 26. So B will be assigned value 26. Okay. Then we have to call as 0. So what it will do, it will go to E0 and the execution will jump to the address uh, E0 and the code starting at E0 will be executing. Okay. So now we have to go to E0. So what it will do? It will provide 0x E0 is doing move C comma B. So it will actually move the value in register B to C. So after this, what will happen? C will be given this value 26. So that is like this. Then next instruction move B to A. So what will happen? Uh, B will be given value of A. So A is 2, so B will also get value 2. Okay. Now kind of swapping E2. So it is move A comma C. So A will be given value of C. C is 26. Then 0x E3. E3 is return instruction. Okay. So return instruction will return execution after this call E0. So it will return the execution to this E0. Okay. And then there will be execution of after this F4. So it will be F6. Now what? Okay. Am I audible? Am I audible? I got disconnected. Okay, is my screen visible? Because I am not able to see my screen. What happened? I don't know. It's visible. Guys can see, but I'm not able to see my screen. Okay, let me rejoin once. Yeah, got it. Got it. Okay. Sorry, I got disconnected. So I was at this. Hmm. So next instruction, what you have given, it's add C with A. Okay. So what it will do? Add C with A. So it will provide me 26 plus 26. That will be 52. Okay. and then 0xF7 is actually end. So it is end of program. So final state of the register, what it will be? A will be having this value 26, C is having 52, and B is having 2. If we go like this, yes, Sivaritha, or according to the course, how it can be 4? Is there any other condition they have provided? Tell me. It's lagging. Let me think. Is there any possibility of hitting 4? I, I don't think you are wrong. Okay. So for it bit, what can be done? Let's see. Mhm. Is there any instruction pointer increment also? It's 8 bit. Then again, all the numbers come within the range, I think. Or we can write this. 26 will be within. 5 bits. 52. I don't think it should be 4. Okay, I will recheck it, but I don't think it should be 4. As per my calculation, 52 comes within 8 bit. Okay, because 2 to the power 8 will be 64. No, 2 to the power 6 will be 64. 2, 4, 8, 16, 32, 64, 2 to the power 6. So 52 overall comes within range. Is equal to 32. How? It is 26, that's right. Again, if I go through this, so 26 what it will be? Um, 26 means 16 and 4, 20. Two is 4. Just a second. So 16, 824. Yes, that will be 26. So if I remove this first bit, then again 2, 8, 10 will be there. No, I don't think either there is some information missing or there is something which is special and we are not getting in that question. Okay, I will look into it. Okay, I think everyone has noted it down. So, Simrita, I will check it once again after this lecture. If there will be something, I will let you know in next one. Okay, so now coming to the questions. With respect to the main function as shown above and its local space, what is minimum number of n0, minimum value of n0? So minimum value for n0, what it should be? Just see here, we have this, okay, n0 here, okay, and n0 is actually starting the local variable space, okay. And in this local variable space, you can go through this. We have these three variables, okay? Z, Y, and dummy, okay? We have to occupy these three variables here, okay? So how much space it should take if I write N0 is actually local variable space. So we have total three variables. Someone write the answer? And all are sort variables. So all are having total 2 bytes of space which they will occupy. So minimum value of N0, what it should hold. Now can anyone answer me? Can anyone answer this? No, 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 Tanmay. We are having sort variables. Sort variables are having 2 bytes. We are having three variables, three such variables. So what should be? Just rethink once. You are very close. Okay. Six. Yeah, good. So we are having 3 cross 2. That is actually 6 bytes. So it should be less or equal to N0. And answer is 6. Okay, good. Uh, in statement 13 of the above C program, a function called surfar 567 is made, which translate into appropriate assembly code. The value of non-negative numbers n1, n2, n3 respectively are. So this is statement 3. Okay, we have z is equal to surfar 567. And now we are having uh, this one. Okay, regarding this. Hmm? So what values n1, n2, and n3 will hold? We have one answer from Tanmay. I will not tell is it correct or wrong. I want some other answers also. If someone has other opinion, okay, no answer till now. So yes, Tanmay, you are right. So what happens if you went through the lectures, you have got something like there was a program where we were calling the function 2 comma 4. This is, I think, lecture 12 or 13. So it is pushed like this. 2 is first, then 4 is above. Okay. So what we are given, we are having something like this, N3, N2, and N1. And we have sort length, sort width, sort height, I think. And we are having 5, 6, 7. Okay. So we will go like this only. Okay. So 5 will be there, 6 will be there, 7 will be there. Okay. Every time we will push something, we will do like this only. Okay. So from here, you can answer all these three. N1 is equal to, that will be 7, N2 will be equal to 6, and 3 will be 5. Any doubt? Okay, I think no doubt. So moving to the next one. Okay, when statement 13 of C program in main function is executed, it performs a function call as shown in the assembly equivalent code at the code segment address 0xC306. After the assembly code executes instruction at 0x306, what is address 1? And the value of address pointed by stack pointer, that is ESP within square bracket respectively. Can someone write the answer? Just remember what is done in the lecture when and it's a simple thing. What happens in case of any stack pointer points to the instruction which executes next. Okay, and if you will go through the lecture, you can get the answer easily. So I am waiting for 1 more minute for your opinions. Right. When we are calling address 1, address starts from 0xc500. Yes, exactly. That is the starting address for this function. And after execution, stack pointer moves to C307. So if, oh my God, what happened again? Okay, okay, okay. Hmm. So in this, we have statement 13, and when we will go for executing this, we will start from here. And what it is pointing to, it is pointing to this one. Okay. So when it is point to this one, the address will be 0xc500. Should point this, obviously. And when it will get executed, the pointer will increment, stack pointer will be there. Okay. So what it will be? Address ESP, comma val2, that is 0x307. So answer is P. Correct. Very good. Before going to this, let me create some basic kind of architecture, how the code is executing for some instructions, so that if someone is not getting how things are happening, he or she may be able to get it. So you may see these questions, but I will ask the answer after I explain it. Okay. So I am just creating it. So what happens generally, we have two things. Okay. Those who are not able to see the lectures can just listen to me. And if you have went through lecture, if I get wrong somewhere, you can just write. Okay. So in general, we have stack pointer and we have base pointer, and in between these two, we have local variable space. Okay. So what is happening in step one of this question? Step one is telling to that we have 0x3300, and we have push EBP. Okay. So what is happening here? We have like what will be the stack after this step? So if you see the memory space, we have this EBP origin. Okay. And we have some start point from here, and we have stack pointer ESP that will be over it start -4. Okay. After execution of first instruction, the scenario will be like this. Then when second step will be executed, what will happen? It is telling to move EBP ESP, means content of EBP, or where ESP is pointing, EBP should point to that only. So if we have start, this is EBP origin, we will be having this ESP start -4, and it is now EBP also. Okay. Now coming to the third step. Third step is just starting the local variable space at 0. Okay. So what is happening here? So we have start pointer, we have EBP origin, and we have EBP pointing to start -4. I'm just writing start as ST now, okay, for simplicity. Now it has created the local variable space. So local variable space will contain all the local variables. So in this case, we have total three local variables. If you have written the program, just go to that and see we have three local variables named as Z, Y, and dummy 2. These three local variables, and these three all are of 2, what we have answered in the first question regarding this. Okay. So that is 2 cross 3 having 6 bytes. Okay. So now where stack pointer will be? Stack pointer will be at start -4 -6. So it will be start -10. Okay. So stack after this step will be at this point. Okay. Now this is the scenario till we went for N0. Now at step 4, what will happen? Step 4 is having push operations. Okay, we have three push operations. If we go through one by one, or we can write it once only. So we are having this EBP or start EBP, which is start minus 4, and there is Z, Y, dummy 2 in the local variable space, local variable space, and what it will be, it is st minus 10, and now we will one by one push the values. Okay, so first we will push values 7, 6, 5, that is n1, n2 and n3. Okay, like we were asked in the previous one, n1, n2, n3. So after each push, as these three are short variables, so we will increment, uh, not increment, means decrement by 2. Okay, so this will be st minus 12, st minus 14, st minus 16. Okay, so here we have done the push operations. Okay, now in next step, what will be done? We have to call address 1. That is actually when we will call the function which is having surface area formula within it. Okay, so what will happen here? We have start, we have EBP origin, EBP start minus 4, then dummy variable 2, Z, Y, ST minus 10, and we have 5, 6, 7, tail ST minus 16. Now what will happen? We will actually put the instruction. What it will be? It will be EIP 0x307. Okay, and the overall, as this is a code line, it will take 4 bytes, so it will be st minus 20, and stack pointer will now point to this instruction. Okay, so it is done. Now what will happen next? So what happens when there is a call of local function? Whenever there is a call of some local function, uh, it is written in that lecture also. So we first post the EIP, and then in EIP we push the local function's address, and when we will return, we will just pop EIP, and ESP will be ESP plus N. Okay, so what will happen next is from starting from starting up to this EIP, the things will be same. EIP 0x307. Then on top of it, there will be EBP start minus 4, because we will call the uh, EBP after this instruction, and after that the stack pointer will be incremented by sorry, not incremented, I am in it's decremented by 4. Okay, so after this what will happen, it's the sixth step. In seventh step we have to move register, so it is move register 1, not move, it's a push. So when we will push it to EVP, and when we will push register 1 and register 2. So what we will do from here, we will just change this EBP start -4, and the EBP will point to ESP is equal to ST -24. Okay, so we are actually taking ESP and putting its value to EBP when we are changing among the registers. Okay, then there is a eighth step, which is actually uh, local variable space creation again. So here also again we will go from start, and we will go up to EBP ST -4, and this is EBP pointing to start -24, and on top of it we are asking for N5, which is actually creating the local variable space. So local variable space is actually SAR and dummy. There are two local variables created. If you see in this code, there are two local variables which are created. Okay, so the stack pointer will be now decremented by 4. So it is there, and ESP is equal to ST -28. Now in next step or ninth step, the stack pointer is now pointed to the next address. So EBP ST -4 and all below instructions are same, above instructions are same, and ESP is pointing to EBP, that is ST -24. Okay. Now in the 10th step, what will happen? It's telling pop 1. So it actually does popping the value of EBP. Okay. Register 1 is having EBP, it will pop the value. Register 2 is actually stack pointer, and in the last step when there is return 0, we actually what we do, we actually pop this EIP also. Okay, that is actually what happens when we execute this kind of code. So what ESP will be ST -16, and it will pop to EIP 0x307. So now if I come to this question, in the case of function call, it is required to restore the context of callee within called function returns back to callee. Okay, callee means the caller function, called function is called function. With this premise, determine register 1 and register 2 respectively. So what it will be? Now, can someone answer? Can someone answer? I actually described it. What will be register 1 and register 2? I told it. Register 1 is where we move the instruction, that is EBP. Register 2 is ESP. Okay. Answer is D actually. With respect to surfar function shown above, its local space, what is the minimum value of N5? This also I have told. Can someone write the answer? Wrong answer will also be, means I will appreciate if someone at least writes some wrong answer. Please. Very good. So as there were two variables, so two variables and those two were short variables. What were two? There was, I think, surfar and these two, SR and dummy. So two variables and two is the size due to the sort. So 2 cross 2, it will be 4. Very good. Now, with respect to surfar function, as shown above, and its local variable space, what is the value of qualifier? Yes, nice sign. What will be the value of qualifier? Can someone answer? No. Yes, yes, fine. Qual is equal to word. Because if we go to decrement EBP, we get local. If we go to increment, we get past parameters. And no, no, not the word. Because local variables are solved. So qualifier will be according to those only. So it will be word. Okay. Qualifier will be word. That is B here. Coming to the next one. So far as shown above, its local variables, non-negative integers, n6, n7, and 8 respectively are what it will be. These are past parameters. not 3. So what will happen if we will increment EBP plus 10, we will go to N6 because it's a length variable. So something like this. We have 5, 6, 7, and EBP is like there. So we will go to EBP plus 10 to get N6, plus 12 to get N7, and plus 14 to get N8. So it will be 12, oh sorry, 10, 12, and 14. What will be the 18th one? Sir, for what is value of L1 as address location? 50C. 50C. So shift left means if we will shift left, EAX, how many times we will shift left means once we will shift left, we will multiply by 2. Okay. So till here we have addition. Okay, we have multiplied all the things till this, and after this we are adding, and then we are shifting left. Okay. So what happens in the shifting? We are having LB plus BH plus HL. That is the formula till now we have, and the overall formula is 2 cross this. Okay. So each times SHL or shifting left actually multiplies by 2, and we actually want to multiply it by 2. So how many times we want to multiply? How many times we want to shift? That will be once only. Okay. So answer will be 1, like that. What will be the value 2? What will be the value 2? Where is value 2? This one. We have to add ESP. Okay. So at 307, we have to add it. Okay. So what we need, we are having 3 variables. Hmm? And for 3 variables, uh, we can go 2 ways. Either multiply by 2, that will take 6 bytes in popping. Okay, so that will provide 6. And if some machine is having, it is in answers that if some machine is having 4 byte, so that will provide us 12 bytes also. So 6 and 12 both are given as answer. What will be the 20th answer? Which of the following statement are true about function call so far? Can someone answer this? It is told in the lectures also. A and C. Yes. Good. Theoretical convention is used and caller performs the necessary operations for stack cleaning up, not calling. Okay, which of the following statements are true about C program and its assembly code? Statements in the address location 0 cross 300 and 0 cross 400 are used to store the context of its respective calling function. Is it true? I will go one by one. Is it true or false? First one. Sir, A and C. So A is correct, yes. A is correct. What about B? Statement in location 306 performs task storing and return address in the register EAX. So is it so? 0x306. These two are the correct because these are storing the context of poly function. That is totally correct. And what about where it went? 306. It calls the address, calls the function actually. So not returning the address, going for function. Statement in address location 0x307 is used to perform explicit stack cleanup by the calling. Yes, explicit cleanup is there. We are actually changing the stack pointer, so explicitly it will be done. Okay, I'm showing it to you, but just for 2 minutes, huh? It's 8:26. 2 minutes I will show this, and 2 minutes I will show the assembly code. So if someone has missed it, just try it. So we had two variables. So first variable was um, in this surf area there were two local variables, and in the main there were three variables, and all variables are short, so there are only 2 bits for variables. That is one thing. And then one more thing I told, that shifting left will multiply by 2 in case of binary or in case of instructions given. So what we will do in the assembly code, we will actually take this formula, we will add it, and after adding it, we will shift left once so that it is multiplied by 2. And we will switch the context when we will call this server function. And in server function, now it's time for this code. In server function, we have register, pushing it to register. So we will push some value to switch the context from EBP and then move the stack pointer value to EBP. And after completing this instruction, stack pointer will be there at 307. So at 8:30, we will go back to this, the remaining questions. Till then, if I try to write what is happening in this 503 and all, think that may be helpful. So what is happening here? We have this 503. Mm, clean it a little bit. So at this point, we are providing SAR is equal to 0 and EBP minus N4 or N4 is equal to 2. Okay. Then in next one, in this N6 and N7, what is happening? We are going for length into width, and that is in result 1. And 7 and 8 is width and height in result 2. And then we are adding result 1 say plus result 2 and adding it to result 3. Something like this. And then we are going for this length into height. We are storing it to result 4. Okay. We are moving and multiplying, moving, multiplying, moving, multiplying. Okay. So we are taking one number, we are multiplying it, we are taking again, multiplying it, and likewise. Okay. So say we are having result 4. Now we have result 3 and result 4. We added both and provided to result 5. Now we have till now we have LB plus BH plus HL. Now we will shift left once so that it will convert to the overall surface area and store it to say result 6. Next, what will happen? I am just storing it. I can just change it to implies sign also. And then dummy is equal to 0 is also there and EBP minus 4 is there. Okay. And then we will return the value of SAR. That is the overall instruction. We will just pop out all the things and we will get the values. So I think you have noted it down. Now coming to the question again. Yes. Statements in address location C302 and C502 are used to set local variable context for its respective function. Is it true? 302 and 502. 302 and 502. Yes, we have created the local variable space. Okay. So it is also true. Last one. Statement in address location 0x511 is used to restore the context of the main function. So 511. Yes, we have actually popped out the register 1 or EVP. So we went back to this context where we were. So last one is also correct. So we are having answer as A, C, D, E. The only wrong answer is B. Now just write this code. We will do next some questions on this. We are having this class test class, the C++ code, and we are given public int AB. We are given a function which returns A minus B, that is subtraction within this class. And in int main, we have this variable z is equal to 0, and then we have created a class test x, and then we provided x dot a is equal to 3, means we have provided value 3 to the variable a of x, and assigned the value 2 to the variable b of x, and then we perform the subtraction and return the z. Okay, so open braces of the function translate the prologue of the function in assembly code. Answer 23 and 22 will be done with this. So just write it in 1 minute, then we will go for answering next two questions. Okay, I think you have noted it down. Now coming to these two questions. Which of the following will be the assembly statement corresponding to the statement 5 of C++ compiles to? Statement 5 we have, and we have these three statements and other none of the above. So just see statement 5 means like this. We are having this one. So what it will do? Option 2 was false. In address 306, task of storing return address in instruction EAX, we were not doing like this. First is clear. We are having we have to store the context of respective calling functions. because first is in 300 we are actually calling this, we are starting with this EBP, and in this we are starting with register 1, storing the calling function. It is calling main, it is calling surface area. Okay. Okay, so when we start some function, what we do, we actually push uh, first the origin pointer, that is base pointer, and then we do something, we push something, and then move that uh, this stack pointer to base pointer. That is all we do. So here also we will do the same. If you will go to the lectures, sir has told it during solving one program that was, I think, in every program he has done like this only. When we have z is equal to x plus y, we again went for this same. There was gi where then again. So we first push this, then we push this counter, then we move this stack pointer to EBP. So all three are correct. ABC, all three are correct. Now coming to this one. Which of the following assembly statement corresponding to which statement 10 of above C++ compiles to? A, C, D, B, E, F. What is statement 10? This one. So pushing EBP will be there, obviously. And this thing again is done. And we have total 4, A, B, and Z. We have 3 variables. So we will be taking total 12 values. Okay. Because there are int and 3 into 4, that will be 12. This will be incorrect. This will be incorrect. None of the above is not option. This is not happening there. Okay. So there is A, C, and D correct. When statement 14 compiles, one of the assembly statements is translate to LEA, ECX, D word pointer, EBP minus val. What is this val? 14. Z is equal to X dot sub. So in this case, EBP will not be going to anywhere. So that will be 0 only, non-negative integer value. Okay. So I think there is some question or not. I think we have done all the questions today. Yeah. So all the questions are done from my side, but I am just there are 15 to 20 minutes. So I am just taking it from the first one. So I'm just briefing what we have done today. Then if there will be 5 minutes, we will discuss something if needed. So this week was all about how compiler works, how compiler provides to the uh, like errors, or there may be assembly code translations with the help of compilers, how these all things are done. So compiler actually takes all program once and then converts it into high level language, sorry, low level language which machine understands, and then uh, there is intermediate part which actually calculates, sorry, converts overall code into um, object code, which gets executed, which may get executed at multiple machines. So, um, the 24, problem number 24. Problem number 24 is actually taking EBP minus 0. So for subtraction, keyword pointer we are taking, but ECX is there, and what we will do here, it is taking x is equal to this, that is equal to x dot sub, and what we have to do, we have to provide some value, like in previous question if we see, um, we had word, so we provided this move and then word pointer, but here we don't have anything to add or subtract. Here we have z, but in z we don't have to subtract anything, like x dot sub is one thing we are just calling, we are not going anywhere, we are not shifting it, we are not shifting the EBP pointer to anywhere, any other address. Okay, that's why the value will be 0. So it is actually LEA ECX keyword pointer EBP only. It will be like that only. And LEA is actually this something effective address, load effective address. Yeah, it's a load effective address. So it is actually taking address only. So we are having address of this instruction, which is at sub function, which will point to sub function. So there is no such offset we have to give. That's why the offset will be 0 only. Okay, you can go to the lectures. Uh, there you can see if there is, we are just taking address. We are not going for more indirections. Okay, so if there is no more indirections, we are having this address only, and address is directly pointing to that subtraction code. That's why we are not going anywhere using some offset. We don't need offset here. Is there any other doubt? Okay, if it's not clear till now, so do one thing. There is an editor which creates the equivalent code. I am not remembering the name which sir uses. You just put this code in that editor. The slides will be available to you after this lecture. Just put this code and see what happens line by line. You will get your answer. I think explanation I am providing is not sufficient enough to visualize it because there is no such code is given. So either I write overall code in assembly language, that will take a lot of time. Okay, so we started with the this one where we just got to know that the macro will be given at the pre-processing time. Then there were statements about linker and executables. Next week is on linker only, and that is not having, I think, these much questions like we have solved today. There may be maybe I think very less questions which are I think like this kind of numericals. So let me check it once what we have in week 4. Yeah, week 4 we have very less questions. So uh, I will take all the questions which I left in the previous week's assignments and last week questions also. And if there is any doubt, you can write on the discussion forum also, but at least till Monday so that I can get it to you on Tuesday because I am also human. I may not be able to answer within that time place. So if you will throw the question to me before one day, I will be prepared accordingly. Okay. So this was the one, and then there are questions related to these problems, and then we had a good question which was about all the things which is covered in this week, how a instruction gets executed, how context switching is done, and how the variable is provided some value, and how this mathematical operations work. Okay, so these are all the things, and yeah, then there was Scholar, which performs all cleanup, and CDECL, which is conventionally used. And then these three questions, which are about how these statements are loaded. Okay, let me check if something is left to be covered. I think I'm done for today's lecture. So we have 7, 8 more minutes. So if I go with something like this, there was one thing more covered that we cannot do something like this. Was Y was Z because there, if we go, we will put it to EBX and then we will go content in content of EBX or ECX or EDX, all the registers. So we cannot do multiple indirections. Like we are doing the indirect addressing, we cannot do in hierarchy. Okay, that's why we are not able to do something like this in the code, in the assembly language code. Okay, so this was the one thing, and yeah, I think all things are covered. I'm just repeating it once. For local variable space, we have stack pointer and base pointer, and based upon this, in between we have local variable space. So when we started the working of that question, we had this push EBP operation which started the origin, and then a stack pointer was about that -4, and then we moved the EBP to point it to stack pointer, and then we put these variables in the local variable space. Then we pushed all three these function parameters, which took 2 bytes, and after that we went to the instruction, and then we just get out of it by explicit switching, and then we actually push the value of register 1, and register 1 was EBP, register 2 was assigned to stack pointer. Then we put the value of stack pointer to the register or EBP, and at last we actually popped register 1, so we got the value at EBP, and then we returned 0. That is actually uh, for instruction register, instruction pointer we popped out, and finally stack pointer was pointing to start -16, and so this was still this, and what is happening in these instructions, there was qualifier for this EBPN -4, that is actually SAR is equal to 0, that is for this instruction. Then we have EAX, which is storing this length, and then we are multiplying it with width. Then we are taking width and multiplying it with the height. Then we are adding these two results. Then we are taking this length into height, and then we are again multiplying it, and we are adding this result, and then we are shifting to multiply it by 2, and then we are storing SAR is equal to that result, and finally dummy is equal to 0, and we returned the SAR, and then we moved the value of register 1 to register 2, that is stack pointer, and we popped out to the register 1. So we popped out this EBP, and moved this register 2 to the next value and returned 0. Actually took out the instruction pointer also. This is how this all thing is done. So at last the code started from main. We allocated the local variable space for this. Then we called this. This took the execution to this one. We allocated this space, and then from there we just took it. We performed it. We first performed multiplications, all these two, and then we added it. Then we multiplied it. Then we added this, and then we went to this dummy is equal to 0. Before that, we shifted it left once to multiply it by 2, and at last we returned this SAR, which is actually stored to this one, this Z, and we stored it to dummy 2, and then we returned Z and converted it to int. So in this way, this program executed in C and in this one. What is happening here? We have provided EX. So after this is for providing the value. Then there is for dummy, and then we moved the value, we popped out and returned 0. Actually took out the control from the program. We went out of the main. So based upon this, we have done these questions. Anything more remained here? Okay, so I think all done for today. Thank you all for joining. I am ending this call. Hope you have enjoyed today's lecture at least. Last some lectures were totally based upon this theory. This lecture was more about problem solving, proper problem solving session from starting up to end. So the questions, the solutions will be provided, will be available to you after this session, and the video will be uploaded to YouTube. You can get it from the master sheet which is shared with you. Okay, thank you all. Thanks for joining. I am ending this call.